Well, hello everybody. So today is my first day back from a very serious bout with the flu, and let me just say that I did not enjoy my experience with the flu at all. But it's good to be back. I'd rather be making math videos than dealing with the flu and all that comes with that. So today came up to solve this kind of problem where we have a probability distribution and we want to calculate the mean, the variance, the standard deviation, and so on. And this is different than calculating the mean, variance, and standard deviation of a data set. Okay, so if I have like a survey of 50 people and how tall they are, calculating the mean, the variance, the standard deviation, that's one thing. But when I have a probability distribution, it's something different, okay? The way that I can understand this probability distribution is based on my initial reading of the information in the question, is that the probability that a student is involved in no activities is 0.058. The probability that a student is involved in one activity is 0.121. So that's what all these numbers mean. So there's the value of the variable, such as 3 activities, 4 activities, 5 activities, or whatever. And then there's the probability that a random student is engaged in that many activities. Okay? All right, so our question is to find the mean, the variance, and standard deviation of the probability distribution. This is called a probability distribution because it links a probability with every value of the variable. Okay? So here's how we can do that. So first thing, when we find the mean is also known as the expected value. The way that we do that is we just add together the value of the variable times the probability that it takes that value. So look at this. Let's look at this side by side. See this together? So value of variable times probability. So one of the values of the variable is that it's 0, and the probability of that is 0.058. And then next value could be 1, and the probability is 0.121. And next 2, and the probability is 0.165. So I do that all the way through the table, and what I end up getting is 3.354. Just, when I did this, I just used my handheld calculator and with whatever you see written right there. Okay? Anyway, so I noticed here it said round to 1 decimal place, so 3.354, it's going to be 3.4. Okay? Now, next we would go to the variance, and that one is the more difficult calculation. Okay? It's not really that hard to do on Excel, but on our tests, we don't have access to Excel. We have StatCrunch, and I'm not aware of any way to do this on StatCrunch directly. Okay, that would just make it real easy. So that's why I'm showing you this on paper. To find the variance, we take the value of the variable, where once again, the values the variable takes are 0, 1, 2, 3, so on and so forth. We subtract the mean, we square, and then we multiply by the probability of that value. Okay, so for example, look at this. So my mean that I've already calculated is 3.354. So starting with 0, the first value of my variable, I take 0 minus the mean, 3.354, and I square that, and then I multiply by the probability that it takes that value, 0.058. See what I mean there? And then I go to the next one. The next value of the variable is 1. I do 1 minus the mean, 3.354, as found previously here. I square it, and then I multiply by the probability that we're at that value of 1, which is 0.121. And I keep going all the way through that table. Now, be careful. I mean, if it comes down to doing this on paper like this, you just got to be careful. Make sure you write all the numbers down and just go nice and easy. Put it in your calculator. Don't hurry. And I got 3.379. Okay. rounding again to one decimal place, I'll get 3.4. So that's how we calculate the variance. It's the hardest one to do just on paper with a calculator. If you look in the view an example, you might find something a little bit easier way to organize what I just told you. I just wrote it all out, but here, like, notice right here, here's the formula that I have. It's like in this table calculates each portion of it together, all in one place, and then separately adds everything together. I don't really know if you would find that easier to do or not. So here I'm just going to write down everything and just say, be careful, go slow, put it in your calculator. All right. Okay, so there's our variance. That's the one we got to be careful with and watch out for. But you see my numbers, and I hope that serves as an illustration to the formula. The last one, the standard deviation, is the easiest one, because once you can get the variance, 3.379 or whatever it is, the standard deviation will be the square root of the variance. All right, and that's going to be square root of 3.379, about 1.838. So I put in 1.8, round into one decimal place as needed. Now, those are the calculations, okay, for the mean, the variance, and the standard deviation. Now time for a little bit of interpretation. So the mean is a measure of central tendency, right? Kind of tells me where the middle is. And so if the mean is 3.4, then I would say, well, the average student is involved in 3 or 4 activities, right? Because that's what this table represented. Like how many activities a random student is involved in, and the odds that that's the case. Okay, so this mean there of those numbers and that data being 3.4, say 3, 4, 3.4 is kind of in the middle. Standard deviation of 1.8 means that the typical number of activities per student deviates from the mean by about 2 activities, right? So we might say that, yeah, in general, we're expecting most of the data to be within 1 standard deviation of the mean. Okay, so if the standard deviation is 1.8, I mean, that's just about 2. So if we round that up to 2, it's safe enough to say that it deviates from the mean by about 2 activities. So like whatever the mean is, I'm expecting typically most students to be involved in 2 more or 2 less, because that's 1 standard deviation from the mean. Okay, so that's the interpretation that those numbers have on top of everything else. Okay, so I'm going to leave StatCrunch out on this one. This is going to be a paper and pencil type calculation. If you've got a nice graphing calculator, it can make some of this stuff a little easier for you. But, given that you've got to work with what you have, if you're like me and you have a simple calculator, then you just have to be careful. It's also not hard to do this on Excel. That would make it a lot easier, I think, but Excel is not accessible during the test. That's just the nature of our proctoring this semester. So give this a shot, be real careful with it, and let me know what you think.